I think we are ready to start the next part. Just wanted to say hello to everyone. Thanks again for coming. And I will try to be as brief as possible because my part of the workshop is actually the least advanced, I would say. But still, I think it's useful. I will do my best to cover like the 3 new functions that are new to Swift. They are like a higher order, I would say, array manipulation functions that are like very easy to learn, but I would say they're super useful, like using them on daily basis, and I'm sure you either are using them already or you will be after after the workshop. So let's start by defining the array. I have it here, so I'll just copy paste it. So this is the array of some of the people we have in the company with the age. That's like real values there. And so the first thing, like the first function that is new in Swift is called filter. And I will try to demonstrate to you like how good it actually is. So let's say we want to do some like a simple operation over the array, which would be we want to like create a new array which would only contain the users whose first name is Martin. We have like almost everyone in STRV's name is Martin, so that's gonna be most of it. So I will first try to show you how it would be, how you would program it in like a traditional way. So basically, if you want to filter the array in like those like a old school imperative way, you would have to declare some new array basically. And then you basically loop over the original array, test each user's first name if it's Martin, and based on that you would append to the new array. You can see that the auto-completion doesn't work like always. So that should be it. Let's see if it actually compiles. And here we can print the new array. So that would be like a traditional way how to filter the arrays. There's some issue in list of oh, here we go. Yeah, the playground is like not the most stable thing. But you can see here that we are getting correct results. We are getting the array of just the users whose names is Martin. So well, there's nothing wrong with this code. It's relatively hard to read given how simple the operation is. So let's try to do it differently using the filter function. So basically in Swift you have this filter function that takes just one argument, which is a closure. And in the closure you're basically supposed to return either true or false based on if you want that element to be filtered out or included. So how do we get to the element? You can use this kind of notation, and basically we are interested in the first name, and we are just gonna test it if it's if the first name is Martin, and that should be it. Let's try to print the array now. So let's give it a. Oh, here we go. Yeah, that error, yeah, disappeared. Oh no, now it disappeared like completely, but you will have to trust me on that. It produces the same result as the previous function, but there are a couple of advantages in using the filter, like the higher order filter function as opposed to using, the previous version. And two of those advantages are actually obvious. It's like more readable and it's quicker to write. But there's actually one more advantage to it, which is not that obvious, which is you're basically, as now we are like more explicit, and we are not like over specifying the execution of the filtering. We are letting the more room for the environment to actually decide on how to execute it. So basically, anytime Apple comes up with some optimization over the filter function, we get that optimization for free, as opposed to using, the imperative way when we like over-specify the filtering thing so much that it's basically impossible for the environment to be, smart about the execution. So that's the filter function. That's like the easiest one to understand. Not that they would be like hard to understand, but still. So the second one, basically, let's say we want to do something else, and we want to basically change that, like reduce the values in that array. We want to basically remove the last name, but still like keep the whole array the same, but just remove the last name. So we basically want to remap the array to something else. Again, there would be like I can show you the traditional way how to do it, which would look something like that. You would have to basically loop over the array and like come up with a new value for each element. And yeah, you can see it's relatively hard to read, like hard for anyone to get into. So let's play a bit more with the map function. And again, this function basically takes just one argument, which is a closure. And we need to basically, what we are supposed to do in that closure is return, basically the closure is going to be called for each element in the array, and we are supposed to respond with a new element. So in our case, that's going to be a dictionary with just the ID, the first name, and the age. We will skip the last name. And basically, not to make it too long, I will copy-paste it from here. Oh, here is just the first name, but like that doesn't matter. So let's try to print the new array. So let's give it a yes. This was done by the collective will of us all. Yeah, so this is it. This is how the mapping function work. It's like super useful if you want to, do like a minor or even like a major changes in each element in the array. And yeah, just feel free to interrupt me with any questions if there are any. Otherwise, I will try to be brief. And so let's go to the third one, which is actually the one that usually developers struggle a little bit to understand, which is the reduce function. So basically, a reduce function is very similar to map function. The only difference is, like why it's called reduce, is because you're basically reducing the whole array into a single object. Like with map function, you're changing like the array to some other array. Like with the reduce function, you're basically reducing the array into a single value. And that value can be, scalar value. It can be a dictionary. It can be another array even. Doesn't really matter. So the reduce function is basically a little bit more like universal. And like, what is it good for? So let's say, for example, we want to count the total age of all of our STRV members in the array, which will be interesting. So how would we do it? Like again, like the old way would be to basically loop over the array, and for each element add to some total age variable, and we would end up with 145. So let's see if we can end up with the same result with using the reduce function. So basically, the reduce function is a little bit more complex. It takes two arguments. The first one is the initial value. Like as I mentioned before, like with the reduce function, we're basically converting the whole array into some like a single object. So how it works is basically the closure is called for each element, and it's called with like as an argument. It takes that element, but also that single object that we want to end up with. And we need some value to start with, basically. So we will start with the initial value of 0. That would be like the initial value of the total age. And then we need to add the closure. And basically in that closure, we have like two values, which is this is that like final return value, that single object that we want to end up with, and this is the element for which the closure is called. So basically, what we want to return is the final value itself plus the age, and the age basically we can extract from the element. We will need to probably change the type, and let's see if we can get the same result. It's loading. Yes, 145. So feel free to like I'm not sure if it was like clear enough how the reduce function works. It's like basically anytime you want to, like you can think of it really like anytime you have an array and you want to end up with a single object, it's like a good candidate for using the reduce function. So that's pretty much it for the new functions over.
I have a comment. I think that the most useful thing on this is also that it's so clear that you split the job into small pieces, which are like just functions to do something. It is worth to mention that you can chain these commands.
Yeah, absolutely.
You can do the math, which selects just the first name, and then you do this reduce to calculate the ages of the Martins, since it's the most common name. What is tricky in this case, what is default in Swift, is that you are producing a new array in this each iteration, which is not so efficient for memory, because you need to then collect it through the R. There is a library which is called sync, which uses the sequence of structure, and this doesn't produce the array in each iteration. It's much more efficient for memory.
That's actually a pretty good point. With I'm not familiar with the library, but yeah, absolutely you can chain those functions, so you can like have them all in one one notation. That's even better.
Is there a shorthand way to sort this array based on age?
To sort it based on age? Well, yeah, there is a sort function.
But a shorthand way, for example, like.
What do you mean?
Like, I mean, yeah, there is a normal sort, but like, you said that you can reduce the number of lines of code. So is there a shorthand way, like, where you don't have to like write the whole?
Well, that would probably not be like a. I don't think we could do it through the reduce function easily. I think that's really what the sort function is for.
So you can just query the
as I mentioned in the sync, there is the order by function, which you can specify just the comparator, and it will produce a new sequence dynamically, which contains the elements of the array ordered by the particular order function.
Yeah, but actually there's the same function called sort in Swift, which you just like pass the comparator to it, and it orders the array for you.
Just to add something, the sort method is one line of code. I don't think you can write less lines of code than that.
Yeah, because it's like it's probably the most already the most simple solution using the sort function. I don't see how it could be.
Sort produce a new array, or is it sorting just the old?
It does produce.
Is this value for value type?
Produces new array
Because
the arrays are immutable.
Yeah, exactly. So it does produce a new array.
It is different from the Objective-C where the sort was defined on the mutable array. If I remember.
Oh, there was both. Yeah, there was like the sorted array using blah blah blah, and the sort array.
Yeah.
There are two variants in Swift as well. There is sort and sorted, which one works on a mutable array and one returns the array.
Yeah, true.
Yeah, but I think that's the difference between mutable and immutable array is basically even when you change the mutable array, you create a new value with the mutation. So it really doesn't mutate the actual object.
There is the sort function which mutates the actual.
Yeah, but I mean in memory that the
Under the hood, it actually. Awesome. So, if there's no more questions, then I think we're ready for 5-minute breaks. Thank you.